Okay, so we've started talking a little bit about fractions. We want to talk more about that today. Remember, we've talked about the idea of 3/4 and what it means. It's not two numbers, it's one number with two parts. The 3, which we call the numerator, is the count, which tells us we have 3 of something. And the 4 is a name, which tells us that what we have is fourths. What does it mean to have a name of fourths? Well, if we go back to the old elementary school illustration, it means that one object can be broken into 4 equal pieces. And of course, the 3 means that we have 3 of those 4 pieces. So that is the picture for 3/4. It takes one object is cut into 4 equal pieces, or the other way of looking at it is it takes 4 of those pieces to make one whole object. We have 3 of them. The first step is to figure out how to rename those fractions. We talked about having 2 feet plus 7 inches or something like that. We can't add them because they have different names, but we can change the names to make them the same. So we need to figure out how to change the name on a fraction. One of the ways we can do that with this illustration, we're going to take each of those pieces and cut them into equal pieces. So pretend these look equal. And we're now cutting each slice of this pizza or pie or whatever you want to think of it as into 3 equal pieces. Now, how many of those pieces would it take to make a whole object? So we had 4, and we cut each of them into 3. So 4 times 3 is 12. And now how many pieces do we have? 9. We had 3, we cut each of them into 3 equal pieces. 3 times 3 is 9. So we now have 9 twelfths. Do we have any more or less than what we did before?
No.
No, we have the exact same amount. 9 twelfths and 3/4 are the exact same amount. They just look different. We've changed its name. We can change a fraction by multiplying the top and bottom by the same number, just like that, anytime we want to. The key is to figure out what number we want to change it to. So we might have something like 2/5. And if we know we want to change that to 30/5, now we have to figure out what do we need to multiply that 5 by, that denominator by, to turn it into a 35. What would be 5 times 7? So we have to do the same thing to the numerator. 2 times 7 is 14. So 14 35ths and 2/5 are the exact same amount. They just look different. Or we might have 5/8, and we want to change it to be 30 seconds. What are we going to multiply the 8 by to turn it into a 32? 4. So 5 times 4 is 20. So 20 30 seconds and 5/8, again, are the exact same amount. Now we can go the other direction as well. We might have a fraction like 48/60. Up here, we multiplied the top and bottom by the same amount to change it. Down here, we can reduce it by dividing the top and bottom by the same amount. What can we divide both 48 and 60 by? 6 works. We divide by 6. 48 divided by 6 is 8. 60 divided by 6 is 10. Are we done?
No.
No, we can still divide both of those by 2. 4/5. You may have been told once upon a time that you had to find the largest number that divides into both of them. You don't. Just define anything. You could divide both by 2 if you wanted to, and just keep going and reduce it down. In fact, once you divide by one number and get the number smaller, a lot of times it's easier to see what else you can divide by. Don't sit there and agonize over finding that largest number. We could have done this in one step by just dividing by 12, but I'd rather have you just start dividing by 2s or 3s or whatever instead of sitting there trying to figure out the 12. Technically, what's going on there? This ties in with our factoring that we did last week. 48, if you factor it, would be 2 times 2 times 2 times 2 times 3. 60, if you factor it, would be 2 times 2 times 3 times 5. And what we're doing is we're canceling those factors. 2 and 2 cancel out, another 2 and 2, 3 and 3, and we're left with 2 times 2 is 4 over 5.
Is there an easier way when your numbers are huge?
Well, like, let's say you have
Like 4 digits.
840 over 900. Let's just start with that.
Okay, sure.
Remember we did those disability rules last week?
So it's 12. So like
The first thing I always look for is a 10. Why do I look for 10s? Because they're real easy to find.
Okay.
Do those both end in zeros?
Yeah.
You bet they do. So I can divide both of them by 10. If not a 10, then I'd look for a 5 because they end in 0 or 5. So now I have 84 over 90. So after 10s, I look for 5s. Well, there's no 5s there. 2s, are they both even?
Mm-hmm.
Yes, they are. So I can divide them both by 2. This is 42 over 45. Can I divide by 2 again?
No.
No. Next one would be 3 because the 3 is easy. If you add the digits together and that sum is divisible by 3, is 42 divisible by 3? Yes, it is. 4 plus 2 is 6, so it's divisible by 3. How about 45? Yeah, 4 plus 5 is 9, so it's divisible by 3. This is now 14 over 15, and that is it right there.
I don't know, whatever the number I had, I swear was like impossible. Obviously not impossible, just very hard.
Sure. If you really get stumped on something, do a factor tree.
Yeah.
Let's say you have like 1,080 over let's do 1,260. You can always factor. Oops. That's not the number. You know they're all living in my, yeah. You can. Well, like this one, I would divide by 10 first because there's a 0, so it's 108 over 126. Then I could divide by 9. Yeah. But if you're really totally stumped and you're struggling, this is 10 times 108, 2 times 5, so those are prime. 9 times 12, 3 times 3, 3 times 4, 2 and 2. So you have what? 1, 2, 3 2s, so 2, 2, 2, 1, 2, 3 3s, and a 5. Like that. Did I get all of them? Is there a fourth 3? No, that's right. 2, 2, 2, 3, 3, 3, 5. Yep. So next, the 1260, do the same thing. 10 and 126, 2 and 5, 9 and 14, 3 and 3, 2 and 7. So I have 2, 2, 3, 3, 5, and 7. I cancel 2. The 4 was split into 2 2s. So the 4 is gone. And a 5, so I have a 2 and a 3 is 6, and 7, 6 cents.
Okay.
So you can always do that. In fact, once we start throwing in variables,
He's all excited. This is going to be hard.
like this, you asked, like 9x squared over 12x. The easiest way to reduce that is to factor. 9x squared is 3 times 3 times x times x. 12x is 2 times 2 times 3 times x. You cancel out a 3 and an x. So you've got 3x over 4. See how easy that is to reduce?
Yeah, I think I came across.
Let's do a few examples of that,
Yeah, let's do that.
since we're having fun with it.
Let's do that one. No, why don't the names have to be the same?
Well, because we're dividing. Fractions are division. We're canceling out, and we're not adding. If we're adding or subtracting, they have to be exactly the same.
Okay.
It's like 18 over 12. 18 is 2 times 3 times 3. X to the 7th is 7x's. 12 is 2 times 2 times 3. X to the 5th is 5x's. Cancel out a 2, cancel out a 3. 1, 2, 3, 4, 5 x's. So you've got 3xx is 3x squared over 2. Now, here's the one big difference. If this were a regular fraction of just 3 over 2, you'd break that down into 1 and 1/2. Since there are variables in here, you do not do that. This is 3x squared over 2. This is not 1 and 1x squared over 2. You cannot do that. It doesn't work that way. No mixed numbers when there's
But if it
variables.
was 2x squared, then you could.
Nope.
For real?
Nope. You would still leave it. You do
Why?
not. If it's a fraction with variables in it, you never change it into a mixed number. It's always left as an improper fraction. If there was an x squared there, all the x's would cancel out, and then there's no variables anymore. It's just numbers, and then you could do that.
But you wouldn't cancel. Because
Yeah, you would. If there was more x's on bottom, we'd cancel them out. The only reason it's left is x squared because there's no more x's on bottom to cancel out.
okay, so if it was 3x squared and 2x squared, then
Then the x squared then you would have done something wrong because the x squared would have had to have canceled out before. If you ended up with any x's left here at all, you've done something wrong back here.
Well, if it was a different number.
How about this one? Let me give you
Yeah.
this one. Like this.
Yeah.
So basically, x to the 5th and x to the 5th divide out and just have 21 over 15. So both of those are divisible by 3. You got 7 over 5. And yeah, that you would want to change to 1 2/5. But we haven't really talked about turning an improper fraction into a mixed number yet.
But
But that's only if all the variables are gone. As long as there's variables in there, you cannot do this. You'd have to stay at 7 over 5 with the variables in it.
okay. Normally, if you have variables, it's going to end with a variable.
Yeah, there will be a variable in it. Oh, let's see here. Let's start looking for a shortcut. Let's try. Something like this. Rather than writing out all the factors, what does 9/12 reduce to? Both of those can be divided by 3 to give me 3 over 4. How about the x to the 3rd and x to the 5th? Perfect. We've got them. We cancel out 1, 2, 3. There'd be left with 2 x's on bottom, x squared. There's a shortcut based on what we talked about last week that we could do here. The variables, x to the 3rd and x to the 5th, where does the largest power at? Top or bottom? Bottom. Guess where a variable ends up? On bottom. The difference between 3 and 5 is 2. Guess what the power in our answer is? 2. So rather than writing them out and canceling like this every time, we can just go ahead and work with those powers. So we might have, what do I want to do here? Something like this. Now I'm going to work with the numbers separately. So I have the 72 over 60. What can both of those be divided by? 12 would work great. 72 divided by 12 is 6. 60 divided by 12 is 5. Can't reduce that any further, so in our answer, the numerical portion is 6 over 5. Now, how about the x's? Is it going to end up on top or bottom? It's on top. The bigger power is on top, so it's going to end up on top. And its power is going to be 3. It's 8 minus 5 is 3. Does that make sense? Now, how about the y? Is that going to end up on top or bottom? It's going to end up on bottom because the bigger power is the 5 on bottom. And its power will be 2 because it's 5 minus 3 is 2. There we go. Let's do another example or so. Tell me where to start. So we're going to separate out the numbers. 25 and 45 can both be reduced by 5. 25 divided by 5 is 5. 45 divided by 5, 9. So the numerical portion of our answer is going to be 5 over 9. Then what? A goes top or bottom? Top with what power? 3. Good. The bigger power was on top, the 8 to the 5th. And 5 minus 2 is 3. Where does the B go? Bottom, and the power of 2. Good. The bigger power was on bottom with the B to the 9th. 9 minus 7 was 2. Where does the C go? On bottom, and a power of 1 or nothing. This is C to the 1, so the 2 is bigger. 2 minus 1 is 1, so it's C to the 1 or just C.
How do you know where it goes on top or bottom?
The bigger power here is the 5 is bigger than the 2, so the bigger power is on top, so A goes on top. Here, the bigger power is the 9, so that's on the bottom, so the B goes on bottom. Here you've got a power of 1 and a power of 2. The 2 is the bigger one, so the C goes on bottom.
Stay ahead of the game.
Yeah, right?
Easy mistakes. Fix them before you start.
Yeah.
I'll let you guys try this one in your notes. I'm going to pause this. So we're going to start out with the numbers here. 24 and 20 can both be reduced by 4. Very good. Giving us 6 over 5. So in our numerical answer, it's going to be 6 over 5. What about the x? Tell me what to do with the x. On top, because the larger power was the 9 on top, and x will have a power of 1, so it's just x. How about the y? Top or bottom? Top, and a power of 8. Good. 24 was the larger power. It's on top, so we stay on top. Then we subtract 24 minus 16. Z. Top, power of 2. Very good. Remember, we said when there's variables, you can never do that. You got to leave it as an improper fraction. Because technically that isn't a 6. That's a 6 times those things. So you can't separate that 6 unless you take those things with it.
Anytime the answer is like 1, it just should be an X.
Just an X, yes.
But you wouldn't give me credit for it, right?
Possibly. For the right price.
Right, now I need another job.
So, anyway. Let's do one more. Let's try that one in your notes quick. So 35 and 49 can both be reduced by 7. Good. So 5 over 7. Then what? End of the third and okay, so we've got the end of the third because the bigger end's on top. 8 minus 5 is 3. But now we've got D, we got M, we got P. M, where does it go? On the bottom, because there's nothing to cancel it out. P on top, okay, that's fine, because there's nothing to cancel it out. Then D goes on bottom, because the 3 is the bigger one. 3 minus 2 is 1, so it's just D. It gets confusing when you have these that don't have anything to cancel with. What order do we put them in? Well, technically, these are all messed up when I wrote them down anyway. If you ever get really confused, you always want to put them in alphabetical order. So technically, 5m to the third p is fine. I should have probably put 7dm on bottom. This is still the same thing. It's just math grammar. You put them in alphabetical order. No, it really shouldn't matter. But if you put them in as MD, there's a chance that my math lab will mark it wrong. That's a very good question. Is that m times d to the third, or is it md to the
Right.
third?
Yeah.
Well, then it would be a different name than the d squared, and you wouldn't be able to combine them.
Well, how would you know?
They would usually put parentheses around them if they
That's
meant to
what I
be
did, I
together.
didn't combine them because I thought it was the
Yeah.
same thing.
They would normally put parentheses around them to clarify that if they wanted it to be md to the third.
That was a trick question.
That was a tough one.
Yeah.
Either one of these is correct, but my math lab may want you to put them in alphabetical order like this. So my math lab may ask for it like this. For me, this would be correct, but if you enter it in my math lab and it says it's wrong, try to just switch the order like that.
I'm afraid there can only be one reduction method.
Wow.
So anyway, what are some applications? Well, this is a really tough thing to put application problems in, but you might have something like, on second shift, 6,500 parts are produced. Of those, 125 are found to be defective. So the question would be, what fraction are defective? There you go. 125 over 6,500, and both of those can be divided by, let's go with 5. We can do that. That would give us 25 over 1,300. And then they can both still be divided by 5 again. So it gives us 5 over 260. Then what?
Just keep going with 5. I have no idea.
Actually, that's not right, is it?
I don't know.
260 isn't correct, is it?
It's not.
1,300 was right, but the 260 is not. Yeah, it is. Okay.
You need some coffee?
Yes, actually, I probably do. We can still reduce by 5. Give us 1 over 52.
Oh my God, did you just-
What?
Yes,
You laughing at my 52?
yes, I was.
Let's explore these powers a little bit more. We've talked about them a little bit. If we have 8 to the third power, of course, we know that means 3 eighths being multiplied together. So, of course, x to the third power is 3 x's being multiplied together. Do you recall, what do we do when we have something like this? What do we get?
So oh,
5 plus 7. We add the powers. 7 plus 5 is 12. So y to the 19th times y to the 23rd would be
42?
y to the 42nd. 19 plus 23. Remember, we talked about this before, how confusing it can get because we're multiplying, but the appearance is, the shortcut is to just add the powers. We can have something like 7x to the third times 9x to the fifth. Is that going to be 16x to the eighth? What did I do wrong? I'm still multiplying the numbers. I multiply the count. 7 times 9 is 63, not 16. I don't just add them. I'm still multiplying. It's just when I multiply the names, x to the third times x to the fifth, even though I'm multiplying, it appears as though we're adding. 3 plus 5 is 8. But that is still multiplication. So be careful with those. And then we also talked about things like this. We're dividing. It's 9 divided by 3 is still 3. But how do we do x to the 5th divided by x squared? It's x to the 3rd, because we're subtracting the power, just like we did when reducing the fractions.
You said we couldn't write 3. You said we can't break that down.
What's that?
You said we can't break that down. It would have to be like.
It comes out even, though,
Why,
you
why
put it
do
over
think
1.
we over 1? Oh.
because you don't need the 1 on bottom. If it was over any other, we didn't break it down, it just divided out evenly. There's a difference.
Yeah, I'm not
It's a hard one. It's a hard one to see. If that were,
I mean, I get that it's 3 volts. Like, I get that.
let's say this. Let's say this is 12y to the 3rd over 9y. Then 12 over 9 would reduce to 4 over 3, right? And the y would be y squared. That cannot be broken up to 1 and 1/3. We cannot break it into a whole number, or into a mixed number. 1 and y squared over 3. That's not the same. But over here, everything on bottom canceled out. If I were going to write that out, 9x to the 5th, 3x squared. 9 factors out to be 3 times 3, x, 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 x. On bottom, it's 3xx. 3's cancel, x's cancel. Everything on bottom is gone.
Okay.
So this is 3 times 3x to the 3rd. You can put it over 1, but you don't have to have the 1. Anything over 1 is just itself. Just like 7 over 1 is just 7, or like that. So even that isn't affected when the variables are there. It's just if this is anything other than 1 down here, you can't split it up.
Okay.
What if we have something like that? Do you recall how we did that? We still have to do that 4 to the power of 3. What is 4 to the power of 3? 4 times 4 times 4, otherwise known as 64. How do we handle the powers? X to the 15th. Because this is saying we take 3x to the 5s multiplied together. Well, 5 and 5 is 10, plus another 5 is 15. Looking familiar? We discussed this a little bit last week. Not really? I think you might have forgotten to do it.
Thursday?
No, I wasn't. I was here Thursday by class, wasn't I? We discussed a little bit of this last week. Thursday we just reviewed stuff. That's okay. We can keep going over it.
You were taking a nap.
You were napping that day? I tend to have that effect on people. So what would this end up being?
Okay.
X to the 12th. Very good. When it's a power of a power, we multiply them. 3 times 4 to get 12. If it was x to the 3rd times x to the 4th, it would be x to the 7th. When we're multiplying, we end up adding the powers.
So otherwise, if it's x to the 3rd, and then the 3rd to the 4th without the parentheses.
Only have the parentheses around it.
Mm-hmm.
Multiply.
Yes. Like something like this. Is that going to be 30?
I would think so, but why is obviously not going to be?
The name, remember, gets taken to the power. That's still 5 to the power of 6. So on your calculator, you have to do 5 caret 6, which it should turn out to be 15,625 approximately. Wish you had that in the bank. So do I. X to the
Would it be 48 then?
48. Very good. Then we multiply the powers. 8 times 6 is 48. Y to the 18th. So the powers do get multiplied. But the number itself, the count, still has to go to that power of 6. So 5 times 5 times 5 times 5 times 5 times 5. How are we doing? A lot of random stuff getting thrown at you. Huh? That was 5 to the 6th. Gives you 15,625. What if I have something like 4/5 to the 3rd?
Can you take 4 times 3 and then back
No, those are not powers, those are numbers. This means 4/5 times 4/5 times 4/5, right? 4 times 4 times 4 is
Yeah.
64. 5 times 5 times 5 is 125. Or you could have just broken it up like this. 4 to the third over 5 to the third, which is 64 over 125. So you might have 2/5 to the power of 6. Well, I'm going to do that as 2 to the power of 6 over 5 to the power of 6. 2 to the power of 6 is 64. 5 to the power of 6 is 15,625. What do you think? Good question. Can we reduce that? Well, could we reduce 2/5? No, we can't. So if we can't reduce it before we take the power, we better not be able to reduce it after we take the power.
That would be a lot of reducing.
That would be. It's a very good question, though. I'm glad you brought that up, Cody. You get your gold star for the day. Although I'm taking it away because you forgot your pencil and notebook.
Wait, but, how do we do powers again in the,
On your calculator,
yeah,
have a caret key. So that.
yeah,
So you do 2 caret 6.
yeah.
It equals, gives you 64.
Why it's called carrot?
It just looks like an upside down caret.
Let's see it more.
Oh, okay.
Then
Right.
5 caret 6 gives you the 15,625. Yeah, it doesn't really look much like a caret, but for some reason they call it that. So I want you to try this one. 7/9 squared. Tell me what you're going to get. – 49 over 81. Cool. How about 3/4 to the power of 7? $2,187 over $16,384. Cool. There's a new quiz due Tuesday, tomorrow at 11:59 p.m.
Which quiz is that then?
Oh, let me double check.
I'm kinda confused.
I believe it's quiz 5, but let me pull it up here.
Yeah.
My computer's going really slow over here. There's also there's a homework that's due today. That's the one from last Wednesday. Then there's going to be a new homework due Wednesday. Okay. Pre-algebra. Still going slow, please bear with me.
How much harder can this stuff get? I'm curious.
Do you ever want to ask that question to a math teacher?
Yeah.
Yeah,
I
it
am.
is quiz 5 that's due.
Okay.
It's homework 6 that's due today. So this is quiz 5. Homework 6 is due today. Homework 7 is due for Wednesday.
Yeah, every time I think, okay, this will be it. This is as hard as it'll get. And then